So just to get started, first let's think about the brute force solution. Brute force solutions are generally not the desired one in an interview, but it gets you started. Like, if the question is really difficult or you don't know about the optimized solution, brute force solution would at least get you started with the process, and maybe then the interview can hint you for a better solution. So in this question, the brute force solution is that you check every possible pair in this array and see if it is equal to target. So imagine like I have this for loop which is going over the whole array, and I have this for loop again j which goes on I plus 1 till the end. So basically for 10 minus 10 I check is 2 plus minus 10 equal to target, is 1 plus minus 10 equal to target, and so on. And if I don't find anything, I move my I to 2. Now for 2 I check from 1, 12, 20 and 4. For 1 I check 12, 24. For 12 I check 20 and 4. For 20 I check 20 and 4. So your I will start from 0 and it will go back to length minus 1, less than length minus 1. Your j will start from I plus 1 and it will go to less than length. This solution would give us the answer. Like whenever you find the pair, you can see that the target is 5 in this case, and when my I would be at here and my j would be here, I see 1 plus 4 is equal to 5. So my answer would have index 2 and 5 here. So whenever you find the answer, you put the I and j in your answer array and return the array. Sounds simple, right? But let's discuss the complexity of this solution. The time complexity for this solution would be O of n square because we are looping over a nested loop, and the space complexity would be O of 1 because we are not using any space. Let's see if we can reduce this O of n square into n. Do we have something better? Yeah. So the next approach would be, let's think about it. What are we actually doing in this question? For every number, we are calculating the plus every time and seeing if this pair forms our answer. But if you think about it, this problem is something like x plus y equal to target. Basically, if you have first number, you do not need to plus every time and see if it is equal. You can obviously predict. For minus 10, for example, if my x was minus 10, basically my y would be 5 minus 10, 15. So if I have minus 10, I would just need to traverse over the array and try to find 15. The moment I find 15, I know that's my answer. So this is what we are going to do in this question. Basically calculating the counterpart of each number and saving it. So we maintain a hash map, key, value. At key we would store the number which is integer, and at value we'll store the respective index which is also integer, right? So this is my hash map. Let's name it HM, right? So I loop over my integer array again from 0 to less than length. Basically we are looping over the entire array. Let's see. For minus 10, what would be my counterpart? Counterpart would be target minus num of I. So basically as we calculated, for minus 10 it would be 5 minus 10, 15. So I'll check, does this hash map contain 15? It does not, because this is the first iteration and our hash map is empty. So if hash map contains 50, if it would have contained this number, then we would have found our answer, right? So we'll keep looking. We'll come to the if block when we find a situation. So we come in the else block. We haven't found our answer and we put it here. HM dot put number, current number, that is minus 10, comma I, which is 0. Why did we put minus 10 here? Because we don't know. We might find 15 here, right? For that we need to store minus 10. Now we come to 2. The counterpart for 2 would be 5 minus 2, 3. So sorry, I forgot to put minus 10 here. Yeah. So for 2, the counterpart is 5 minus 2, 3. Does my hash map contain 3? No. So you put 2 here, the current number, and you put the index. Basically, now we'll try to find, if we find a 3, the counterpart for 3 would be 2 and our hash map would contain that. So we'll find the answer. Let's come to 1. For 1, the counterpart is 4. Does my hash map contains 4? No. So we put 1 with index 2. We come to 3. Basically the value is 12. Does my hash map contain 5 minus 12 minus 7? No, it does not. So I put 12, 3. Now I come to 20. The counterpart for 20 would be 5 minus 20 minus 15. Does my hash map contain minus 15? No. So I put 20 and the value is 4. When I come to 4, the counterpart for 4 would be 5 minus 4, 1. And my hash map in fact contains 1. So I come in this block. So when it contains 1, I get both the indices. My first index would be hashmap.get complement. Basically the counterpart's value, which was 2. So basically you get that value, and the second would be the current index itself, basically I, and you return answer. So this is the optimized way. Let's see the trade-offs that we did. For space, our space complexity is O of n because we just looped once, and our time complexity would be O of n2. Basically, if you see in detail, the worst case scenario which we had this time, we needed to store n minus 1 numbers in the hash map. So basically the space complexity of O of n and time complexity is also O of n. So this is done. See you in the next video. Bye.